Hello, Rachel.
Hello.
Morning.
Good morning for me.
Yeah, for you. All right, so let's go to linear inequalities with one variable. So before solving any linear inequality, let us try to solve one of the linear equations. For example, 2x squared minus 3x plus 4 equals 9x squared. Well, it's not linear equation. I will write linear equation first. 3x minus 9 plus 4 equals negative 9x plus 2.
I can't see.
You're not able to see anything?
No.
Oh, that means I have not shared the screen yet. All right, so this is here. Is it visible now?
Yes.
So we're having 3x minus 9 plus 4 equals negative 9x plus 2. Whenever you're having this type of equation, try to have those terms containing the variables on one side and other terms on the other side. Try to have those terms containing the variable on one side and other terms on other side. So if it is 3x here, it's containing a variable. Negative 9x here, it's also a term containing a variable. Try to keep them on one side. Let us put them on the left side. So in order to put them on the left side, we need to eliminate this negative 9x on the right side. How can we?
Add it.
Right. So how much should that be? 3x plus 9x.
12x.
Right. And how much is negative 9 plus 4?
Negative 5x.
But there's no 5. There's no x here. So we'll write negative 5 only. Right?
Yeah. I was
Okay. So equals negative 9 positive negative 9x positive 9x is canceled, and you're left with 2. Right?
Mhm.
But we want only x. We have to calculate the value of x. For that, we need to eliminate 12 also, and we need to eliminate this negative 5 also. And I told you, try to eliminate first, which is in addition or subtraction. So this negative 5 is in subtraction. We will eliminate this first. How can we?
Add it.
Right, adding 5. So 12x equals
2. I mean, no. 7.
7. And after this, how can we get only x?
Divide 12.
Both sides, yes. So you'll get x equals 7 divided by 12, and that is the answer, right? X is equal to 7 divided by 12. So that is the answer for this equation, right?
Right.
Now let us have one inequality now. The inequality is 3x plus 4 is greater than 2x plus 1. How to solve the inequalities? Exactly same as we solved the equation, except only one thing. We have to follow exactly the same things, same rules, same procedures as we did right now while solving an equation, but there's only one difference, and that is whenever you multiply, you write it somewhere, whenever you multiply or divide the inequality, multiply or divide the inequality with negative number, the inequality with the negative number, equality with a negative number, then the inequality changes the direction. Inequality changes the direction. The greater than will become less than. Greater than equal to will become less than equal to. Inequality changes direction. This is the only difference between the two: solve an equation and solving an inequality. So whenever you multiply or divide the inequality with a negative number, any negative number, the inequality will change the direction. Greater than will become less than will become greater than or equal to will become less than or equal to. Whenever an inequality is multiplied with a negative number, the inequality will change the direction, right?
Right.
All right, so let us do this. 3x plus 4 is greater than 2x plus 1. The same thing, we will try to keep the variables on one side. So which thing should we shift to where?
2n should be shifted to the left.
Yeah, 2x, right? So how can we do that?
So subtract 4.
Yes, subtracting 2x to both sides. Subtracting 2x to both sides, right? You're shifting 2x to the left. So first you will subtract 2x to both sides.
It's 1x and then cancels.
Yes, 1x plus 4. 4 will also be there, right?
Right.
Is greater than 1 because 2x and 2x will cancel out. 2x and negative 2x will cancel out. Now 1x, we write it x. 1x and x is one and the same thing. Plus 4. How can we eliminate this plus 4?
Subtract it.
Right? Subtracting 4 to both sides. You'll get x is greater than 1 minus 4. How much is 1 minus 4?
-3.
That is the answer. So x has to be greater than -3. That was here also. X has to be greater than -3 for satisfying this inequality. 3x plus 4 is greater than 2x plus 1. That means what values of x will you put in this inequality to make it true? To make it true. I'll take an example. It's telling you x has to be greater than -3. Can you give me any number which is greater than -3?
2.
2. So can you plug in 2 to this inequality here? 3x plus 4 is greater than 2x plus 1. Plug in 2 for x and see where the left side is greater than the right side. 3 times 2 plus 4. How much will that be?
So 3 times 2 is gonna be 6, and then plus is 10, and then 2 times what?
You
2
have
times 3.
2 times 2. You
6.
have put in 2.
Oh, 2 times 2 is 4 plus 4.
4 plus, it's 1 there.
Plus 1.
How much is that?
That's 5.
So isn't 10 greater than 5?
Yes.
That's right. Now, can you give me some number which is less than -3 and plug it in there?
-4.
So can you plug in -4 to this inequality and tell me?
3
Mm-hmm.
-4 is -12 plus 4 is -7.
Again?
No, it's not -7. -8.
Yes, right. So -8 is greater than 2 times.
2 times -4, so -8 plus 1 is -7.
So is -8 greater than -7?
Yes.
Are you sure? The more the
Oh,
number being negative, the lesser it is, isn't it?
it's less than.
So it's not satisfying the inequality. It's wrong. -8 is not greater than -7 because we put in the value of x as less than -3, so it did not satisfy it. So we are right. So we can say that the value of x has to be greater than -3 in order to satisfy this inequality. Right?
Right.
All the values of x which are greater than -3 will make this inequality true. And if you're putting any value of x which is either -3 or less than -3, will make this inequality hold false.
Makes sense. I see.
Right. Now let us do one more example. Can you try the second one? 6x minus 32 is less than 10x minus 12. Do it on the rough paper.
Where is it?
I will highlight it. 1 second. Are you able to see that?
Yes.
One thing you have to remember, that whenever you multiply or divide by a negative number, the inequality will also change the direction. At that time, you will change the direction of inequality if needed for multiplying negative number.
I did not remember.
You do not remember?
No.
So I need to do this again. I need to tell you this again. I told you here.
I remember it, but I didn't remember it in the moment. But now I remember you told me.
Okay. So try to solve it and tell me what you're getting.
I got 9.
You
But
got
I think I did it too far because I have to have something that says greater than.
All right, let's try to do this together. You will tell me what to do. 6x minus 32 is less than 10x plus 12. So what was the first step you did?
So I added 32, and
Right,
then
right. So
there's
first of all, we'll add 32 step by step. So -32, +32 will cancel out. It'll become 6x is less than 10x. 12 plus 32 is 44. And then what you did after this?
What I did was I added 44 to 10x. I'm not sure about this step.
You added 44 to 10x.
Yes.
But I have also done that. Like when I added 32 to 12, I got 44, and that is already in addition with 10x. So if you're adding 44 to 10x again, if you're adding 44 to 10x, what's happening to this? 1 second. If you're adding 44 to 10x again, you'll get 88, because you can't add 44 and 10x because these are unlike terms, right?
Mm-hmm. Oh, you cannot add like terms. I forgot. You can only multiply and divide them.
Yes. Yes. So try to do that again. Don't combine the like terms.
So 6x is greater than 10x plus 44. Should I do another step? Like, I think that I should.
How did you know that 6x is greater than 10x plus 44? It's showing you the inequality sign is less than, right?
Yeah.
So do you wake up at this time normally, usually?
It's like 30 minutes later, usually.
Oh, okay. That's a good thing. 6x minus 32 is less than 10x plus 12. So I'll write it here. 6x minus 32 is less than 10x plus 12. So what is the first step which I told you? Keep all the variables on one side, isn't it?
Mm-hmm.
So where are the variables? 6x is on the left and 10x is on the right.
Right.
So
So
what
I
you
should have done is I should have added 10 to 6.
Will you add 10x to both sides, or will you subtract 10x to both sides?
Subtract 10x to both sides after I had subtracted 32.
Take one step at a time. If you want to eliminate this 32, then let us go for 32. If you want to eliminate this 10x, then let's go for 10x. Tell me, what should I do first?
Oh, the first thing is to add 32.
Okay.
And then add 32 to 12. So why I flipped the sign is because it was negative 32. But it's adding, it only goes for multiplying and dividing.
Exactly. It only goes for multiplying and dividing. So the first step, you're telling me that you're adding 32. Okay, I add 32. Negative 32 and plus 32 will be 0. It'll be canceled. So I'll be having 6x on the left side less than 10x plus 12 plus 32. That means 10x plus 44, because 12 plus 32 can be combined. 10x cannot be combined with 44 because these are unlike terms, right?
Right.
And then you got 6x is less than 10x plus 44. What will be the next step?
Now add 10.
So if we'll
No.
add 10, we'll cancel.
Yeah.
So 10x and 10x will cancel, or positive 10x and negative 10x will cancel.
Oh, actually, yes. Subtract 10x and then subtract 10x from 6.
1 second. So you're subtracting 10x both sides, right?
Right.
How much is 6x minus 10x?
Negative 4x. So should I have subtracted 6x instead?
As no problem at all. If you're getting negative 4x, no problem at all. Keep it as it is. If you want to subtract 6x to both sides, you can do that thing also. But if you're subtracting 10x to both sides, no problem at all. Keep it as it is. Let us see what's gonna happen. 10x and yeah, and then you'll be having how much on the right side?
44.
Correct. So in order to get only x, what you will do with this -4?
Divide it.
Dividing by -4 to both sides. Now you are dividing a negative number.
And this will be 11.
So it'll be 11 on the right side, -11, sorry. But what will happen to the inequality?
It will flip. This
Correct.
is where it flips.
Yes. So x will be greater than -11. So x is greater than -11. This is the answer.
Mm-hmm. I'm following the concept now.
Oh, great. Okay, and we'll do the questions. We'll be having more questions for this, but till for today, we'll start the next thing. That is properties of integer exponents. We have already done this, but we need to revise it a little bit. 2 raised to the 3 times 2 raised to the 5. You remember? When you're having same bases in exponents, in multiplication, you will add them. So it'll be 2 raised to the
7.
5 plus 3 is
8.
Yep. And power raised to the power, 2 raised to the 3 whole raised to the 5. You will multiply the powers. Whenever you're having a power raised to the power, you will multiply the powers. How much will it be?
15.
Correct. So if you're having x raised to the -3 whole raised to the -4, how much will it be?
2 to the 15. Oh, you're talking about the one on the left.
Yes.
That would be this would be 27.
This is 4 actually on the top.
So this would be 12.
Right, x to the 12, positive 12, correct. And the third thing is if you're having 2 to the 3, if you're having 2 times 3 times 4 whole raised to the power 5, then you can distribute this power 5 to every number. It'll become 2 to the 5 times 3 to the 5 times 4 to the 5.
Got it.
And moving to the next page. Here. Okay. So this is, again, the same thing here. If you're having different numbers or variables in division, for example, 2 times 3 times x divided by y times z, this whole thing is raised to the power 4. That means you can distribute this 4 to everything. 2 to the 4 times 3 to the 4 times x to the 4 divided by y to the 4 times z to the 4. Are you following?
Yes.
So what will be 2 over 3 raised to the power 2?
This would be 2 times, 2 to the power of 2 times 3 to the power of 2.
Divided by 3 to the power 2, right?
Right.
Wherever it is, it will be having that power which it is raised. And the fifth point will be anything raised to the power 0 is always 1. Anything raised to the power 0 is always 1. That anything cannot be 0. It can be maybe 1 or some variable x or some 99. Anything raised to the power 0 is always 1. For example, 39 raised to the power 0 will be how much?
39.
It'll be 1. That's what I'm saying. Anything raised to the power 0 is 1, always. There's only one answer to this, 1. What is 429 raised to the power 0?
Zero.
No, that's what I'm saying you. Whenever you raise the power 0 to anything, you are getting 1. You will always get 1. Anything raised to the power 0 is 1. What is x times y raised to the power 0?
1.
1. Yes. What is 99x divided by 44y whole raised to the power 0?
0.
Again 1. Power is raised to the 0.
Oh, I meant 1. That's what I meant.
So what is 2 times 3 times xy divided by yz whole raised to the 0?
1.
1. Correct. Anything raised to the 0 is always 1. 1 raised to the 0 will be
1.
1. X raised to the 0 will be
1.
1. So remember this thing. Whenever you're having a power of 0, the answer is 1.
It's also for 1.
Yes, for 1 also. Exactly. For 1. Except for 0. You can't say this thing for 0 raised to the 0 is 1. No. Only this thing is an exception. 0 raised to the power 0. You don't know that. So you cannot say it's 1. Other things you can say it's 1. -1 raised to the 0, it will also be 1. -99999 raised to the power 0 will again be 1. So anything raised to the power 0 is always 1. Got it? Great. So one more thing which we did before is that if you're having a negative power in the denominator, for example, 1 divided by 2 to the -2, you can write it in the numerator, but you have to change the sign of the power. You can write 2 to the -2 as 2 to the 2 in the numerator. It's one and the same thing. As we did an example also yesterday, that 0.0625 we got by using two different things. 1 divided by 2 squared and 2 raised to the power -2. It is same. When I solved 1 divided by 2 squared, I got 0.0625. And when I solved 2 to the -2, I got again 0.0625. So I can say that 1 divided by 2 squared is equal to 2 to the power -2. That means what is happening? The power is changing the sign. So you can shift them. You can shift the person who is in the first floor, you can shift it to the second floor, and the person who is in the second floor, you can shift it to the first floor, but you have to change the sign. You have to like change their, dress or something. So for example, you're having 3 to the -5. If you want to write it in the denominator, how will you write it? Change the sign of the power.
To positive?
Yes. Whatever the sign is, change it. If it's negative, change it to positive. If it is positive, change it to negative. Right?
Right.
What is 3 to the 5 if you want to change it to the denominator?
-5.
3 to the negative 5, correct. So if you're having 2 squared divided by 2 raised power minus 4, and you want to write this 2 to the power minus 4 in the numerator, what you will write? First of all, you will, yeah.
Would it be 2 to the 2 and then parentheses to the power of 4?
Correct. It'll be 2 to the power 4, but you're having 2 to the 2 in the numerator also, so you can write that again. So 2 to the 2 is as it is, 2 to the power 2 is as it is, but 2 to the power negative 4, which is in the denominator, I have put it in the numerator with the changed sign.
I see.
It'll be same. And then you can solve it. 2 to the power 2 multiplied by 2 to the power 4 is how much?
4 to the power of, do you add the exponents? No. Okay. So this would be
What is the rule for the exponents when you're having exponents in multiplication?
4 to the power of 6.
What? Can you repeat again?
4 to the power of 6.
The first rule is when you're having same bases in multiplication, you will add the powers and keep the base as it is. You will not multiply 2 and 2. 2 is there. And then you had to add 2 plus 4, that's 6.
Right.
So 2 to the 2 times 2 to the 4 is 2 to the 6. This is the first rule of exponents. And what is the second rule? When you're having division, when you're having same bases in division, what you will do with the powers?
I think it was that you have to change their sign.
When you're having same bases in multiplication, you will add the powers. 2 to the 2 times 2 to the 4 will become 2 to the 6. When you're having same bases in division, you will subtract the powers. So you'll keep 2 as it is and then subtract the powers. 2 minus 4. Right?
Right.
Now I'll give one more example. 2 to the 2 divided by 2 to the negative 4. What is the second rule of exponents again?
You have to subtract the exponents. So this is 2. And then what is the thing on the top?
2 to the 2.
So this would be -6, 2 to the -6.
You're subtracting the powers, right? So 2 is 2, the base 2 is as it is. 2 minus -4.
Oh, this is positive. Okay. So
how much will it be? Two minus -4.
-2.
2 minus -4.
-6.
Subtracting a negative number is as if you're adding it.
Adding -2.
So you're adding 4 to 2.
-6.
You're adding positive 4 to 2 because I told you whenever you're subtracting a negative number, that means you're adding this number. Subtracting a negative number means you're adding it. 2 plus 4. Whenever you're having negative in front of negative, it will always be positive. So negative is in front of negative, it'll be positive. right? 2 minus -4 will always be 2 plus 4. It'll be 6, not -6. Whenever negative is in front of negative, it will always, always, always be positive. 3 raised to the power of 4 minus -6. If this is the question, negative is in front of negative, it will be positive. 3, 4 plus 6. 3 raised to power 10.
I see. So we should probably review it tomorrow.
Yeah.
I
What?
I have to leave now because it's the
Yeah.
30 minutes.
Yeah, that's what I was trying to say to you, that do we have to continue or we can stop? So we'll stop here. And tomorrow, what time?
Tomorrow should be 8 p.m.
8 p.m. Okay, fine. So tomorrow we'll meet at 8 p.m. Thank you.
Thank you, sir. Have a great day.
Okay, thanks a lot. Bye.